Hi, this is Chad, and today we're going to go over the cluster architecture part of Kubernetes. So Kubernetes is a platform for deploying distributed applications, and as you can see in this diagram here, we have one application on the left-hand side with the kind of tan background, and of that single application, we have multiple microservices. So these microservices are isolated units of an application that serve one purpose and one purpose only. That's the point of a microservice, is to really do one thing very well. And you'll see here that the cart service is one microservice, the payment service is one microservice, the cache, web front end, identity, etc. And because they're all isolated, they can run their own language. So there's no dependency or framework that they have to be built within. So you can make the cart service in C#. You can make the shipping service in JSpring or Spring Boot. You can, make the identity service in JavaScript, etc. So we can really have the freedom to use all these different frameworks, whatever works better for the job or the task at hand, or the whatever you're building at the current time, to create the best efficiency and optimization for that application or that microservice. And then you can deploy all of that to Kubernetes. So we're going on to the right-hand side here, and we have the architecture of Kubernetes, which consists of a node, a pod. Each node has a kubelet service running on it. It's a daemon that runs on the node itself. A node is usually a VM in most cases. Kube proxy, which helps with the communication between nodes. And then the control plane components, which also reside on a node, but a special kind of node, a control plane node. And then on that control plane node, you have the controller manager, API server, scheduler, and also core DNS, which is responsible for resolving host names to IP addresses inside the cluster. So let's go through a couple of examples of how we would go about navigating our cluster and taking a look at that architecture from the command line. So we can go to a browser and go to killercoda.com/playgrounds/scenario/Kubernetes. And we'll be able to work with a pre-existing or pre-installed cluster, I should say. So within this cluster, as I said, there are nodes, but there's one special node called the control plane node. And so if we do kubectl, or I can do K for short, get nodes, or NO for short, I like to abbreviate to save some typing there. And if you see, we have an alias that's set up. That alias is K to kubectl to save some typing, because I always mistype kubectl. It doesn't matter if it's CLT or KUB instead of KUBE. But anyways, we have a control plane node, which houses certain pods that are the control plane components. So if we do kubectl or K, get pods in the in all namespaces, that's what the capital A means, we'll see that there are a number of control plane components running, and we can see that they're running on the control plane by doing a -O wide after that command, and we'll see it's kind of small here, or it's kind of large here, so we'll minimize it. And so just to look at this in all one row here, we'll see all these components are running on the control plane, such as Calico, which is a type of Kubernetes controller, Canal, which is the CNI, or the cluster network interface. We have etcd, which is the configuration, the data store, configuration data store for the cluster. We have the API server, which is the main entryway into the cluster in terms of authentication and authorization. And then we have the controller manager, which makes sure that everything's running as it should. And, we'll respin up pods and be able to manage the ongoing state of the Kubernetes cluster. We have the kube proxy, which I said before is helps communication between nodes. And then the scheduler, which is what we call in Kubernetes is scheduling a pod to a node, which means you are allowing that pod to run on a certain node. And the scheduler determines, okay, this node has more resources available, so we're going to go ahead and schedule that pod to that node, and then it runs on that node. So let's clear the screen, and I'll zoom in again so you can see better. And so if we do kubectl get services and daemon sets, we'll notice there's a number of services which allow cluster communication. In this case, there's the Kubernetes default service, which helps with communicating inside the cluster. And you know that by the type being cluster IP. The kubedns service, which helps resolve DNS names. And then we have this thing called a daemon set, which a daemon set just means that each one of those pods is running on each node. So there's one per node. That's why there's two in this case, because we have two nodes. And canal, again, is our CNI, and kube proxy, again, is our communication mechanism between nodes. A couple other things we can explore here is the authentication mechanism that we're using kubectl to authenticate to the Kubernetes API. So we can do kconfig view and see that this client certificate essentially allows us to use the client certificate data and client key to authenticate to Kubernetes. And the Kubernetes API is located at 172.30.1.2 and on port 6443. And we can check out all the resources in our cluster by typing in kubectl API-resources. And these are all the resources that could potentially, let me pipe it to less so we can see it one at a time here. And these are all the potential resources that could be created inside of a Kubernetes cluster. So I'm not going to read each one of these. You can follow along and do these commands as well. But there sure is a lot of different resources that you can create in Kubernetes. Another cool command is kubectl cluster info, which allows you to quickly view where the control plane is running at and also where core DNS is. And that's the location inside of the API. If you wanted to check out what version your control plane components are running at, you could do kubeadm upgrade plan. Kubeadm upgrade plan. Perhaps I should alias kubeadm as well. And so we'll see the control plane components, which again are the API server, controller manager, scheduler, kube proxy, core DNS, and etcd. You'll see their current versions and what version they could be potentially upgraded to with that target column there. So this is an easy way to upgrade your control plane components to either patch some bugs or get additional features. And this is for clusters that are built with kubeadm in this case. And so last but not least, we have kubectl get events, which allows us to monitor our Kubernetes cluster and check for events such as pods spinning up and getting killed. We have leader election, as we can read here. We have images that have pulled. There's right there. There's the killing of a container and it being restarted, and so on and so forth. So these are all the. Here's a failed mount one, And so we can see all the events in our cluster to be able to know what's going on in our cluster and what could potentially go wrong. And so this is where we check to see if there's any problems with our cluster.